Can you hear me, sir? வியாபாரம் எப்படி இருக்குன்னு Vidya left the meeting.
Good morning, everyone. Welcome to the session 2 of day 2. This session will be handled by Dr. C. Sharmila, Associate Professor, Department of EEE, Anna University, Chennai. She will be handling about IoT for PQ issues and enhancement PQ in smart grids. Dr. C. Sharmila holds a BE in Electrical and Electronics Engineering, ME in Power System Engineering from Annamalai University, Chidambaram, and a PhD in Electrical Engineering from College of Engineering, Guindy, Anna University. At present, she holds the post of Associate Professor and Professor in Charge, Power Engineering and Management, Department of Electrical and Electronics Engineering, CEG Campus, Anna University, Chennai. She was also the Assistant Director, Center for Entrepreneurship Development, CEG, Anna University, Chennai, during 2015 to 2018. She had done a number of consultancies on renewable energy systems, such as solar photovoltaic power system, power quality measurements, and design of compensators for industries. She has coordinated and organized several short-term courses on power quality for Tamil Nadu State Electricity Board Engineers, India. She has also delivered several invited talks and trained 1,000 plus engineers on the importance of power quality standards, and design of SPV power system for more than 12 years in leading organizations such as CII, FICCI, CPRI, MSME, GE, and APQI. She has received in the year 2011 a grant from CTDT, Anna University, for a 2-year project on energy efficient solar-based lighting system for domestic applications. She has also received in the year 2020 a research grant from AICTE RPS, New Delhi, India, authored in International Journal, 60 papers in international and national conferences. She has also authored or co-authored 5 book chapters, edited 2 books, and authored 1 book. Her area of interest include power quality, power electronics, applications to power system, smart grid, energy storage system, renewable energy system, electric vehicle, battery management system, and electric vehicle supply equipment. She is a member of IEEE, Fellow of Institution of Engineers India, Lifetech member of ISTE, CVIP New Delhi, India, and SSI India. She has a teaching, research, and consultancy experience of 19 years in the area of power quality and power system. We are here very proud to have her for this session. I now, with no further delay, hand over the session to Dr. Sharmila ma'am, and she will be taking over the session. Thank you.
So thank you very much, sir, Dr. Jagdish sir, and Madam Anita, I think, right? It's a great privilege
Yes,
for
ma'am.
to be here as one of the speaker, and I must thank the organizer, Dr. Jagdish, who is my very good friend since we worked together in SRM Engineering College, and he was a very like active and nice person. Like he used to help everyone. And whenever I remember Jagdish Kumar, I recollect those things. And he's having a good leadership skills also, that which I could witness from this seminar. Like he initiated me 11:15 the program starts, so he made me to be ready by sharp by 11:30. So the entire perfection goes to Dr. Jagdish Kumar, and I congratulate him for organizing this workshop. And it's a very need of the hour what sir has coined the program on the topic of IoT. And today, like electric vehicle, IoT is also gaining lot of momentum, and most of the people are talking this word Internet of Things or Internet of Everything. And you also since yesterday had lot of deliberations about this topic called as Internet of Things, if I'm right? So there will be different applications of IoT, and one application I have chosen is on power quality. You can all see my window. Can you see my window, or just wait? I think. Okay, now I think you can view my window. So thanks once again, Dr. Jagdish sir, for giving a very good introduction about me. Once again, hello. Sir, I'm in a meeting, sir. Who is this? From? Sir, please can you give me a call after some time? Now I'm in a lecture, online lecture. Evening you call me, sir. Evening. Okay, thank you. Sorry. So my topic for lecture today is IoT for PQ monitoring in smart grid. I hope the window is, my presentation slides are viewable, madam? Anita madam? Madam? Madam, can you see my slides?
Yes, ma'am, it's visible.
Okay, thank you. So that is a problem here in this online lecture. We cannot see the people, right? So anyway, if you take the traditional power grid, it is consisting of a large number of loosely interconnected synchronous machines, and they are going to perform three main functions. You all must be aware of it. The three main functions, you call it as a generation, transmission, and distribution of your electrical energy, in which your power flow is going to flow only in one direction. That means that the utility is going to generate the power and the consumers are going to get the power. There will not be any bidirectional flow as like in a smart grid. So what happens, a large number of power plants are going to generate this electrical energy mostly by burning the fossil fuels like carbon, and sometimes it is also a nuclear power plant, means it's a uranium based fuels. So after burning, the power is getting generated. Now it is going to be transmitted via the transmission lines, and these load centers will be located at the remote end, where you are going to connect to the load centers with the help of high voltage transmission lines. So what happens now, your power which is being generated from the generating end is being transmitted via high voltage transmission lines and getting distributed into the electrical distribution system, whereby the end users can get the power delivery. But sometimes the majority of the end consumers may get reduced voltage because of the drop in the transmission system. So each grid is actually being controlled centrally, and they will be monitored to ensure that these generated power are given to the destination, that means to the consumers, and you are going to have these as a entity you having owned by a single utility called as Tangentco. For our state, Tamil Nadu state, we call it as a Tamil Nadu Generation Company. They are going to provide your electrical energy to the consumers, and they will be billing the amount for the consumption of the power. So this traditional power grid worked well, very well since 1870 until 1970. So what happened after 1970? I'm trying to give some scenario or some background why we are discussing today IoT, and how IoT is going to help in smart grid, and in smart grid how did this power quality come. So that's why I'm giving some small introduction before directly going on to the topic. Hope you will all enjoy this small story what I'm trying to tell you about the background. So this forum should be a mixture of electrical, electronics and communication engineers, I hope so. So to the common, I've just, for making understanding, I'm giving the scenario. So our electricity started its inception since 1870. Until 1970, we didn't have much kind of intervention of these smart gadgets or etc etc. So the demand was growing exponentially since 1870 only, but the generation was never equal to the demand, because demand was something very high when compared to the generation. So what happened was, in 1970 there was the introduction of electronic devices, which was trying to help us in quantifying or accounting for the total electricity demand, and you will be having these electronic devices which can be embedded onto the existing traditional power grid. So since 1970 onwards, other new revolutions started coming, like your renewable energy penetration started coming, and that is 1980 onwards we had a wind penetration into the grid. Then now if you see in the present days, lot of solar is being pumped, and again electric vehicles are also likely to come into the existing infrastructure. So we need to have a bigger challenge. That means the power grid are going to face a major challenge because of the growing energy demand, as well as the electric power has to supply reliably and securely to the consumers. And we are the consumers, right? We need to have the accounting for the energy, right? And we need to have a good infrastructure so that our things are going to be possible, our ambitions are going to be possible. So after 1970 only, a lot of initiatives came out, and we started the revolution in information and communication technologies also started becoming very prominent, and this resulted in an effective and reliable as well as secure and sustainable kind of a transmission system which was overlapping with the traditional power grid. So that was nothing but called as the smart grids. So these smart grids are otherwise called as bidirectional grids. Like, there can be a bidirectional communication can be created in these smart grids. So what is the meaning of bidirectional communication flow? That means there can be an interaction between the providers, service providers. Who are the service providers? For our own state, for the state Tamil Nadu, it is Tangentco. There can be a communication flow between the utility board and the consumers, whereas this was not possible in the existing grid, which is the conventional grid, where it was only unidirectional, and the service provider was able to supply the power to the consumer alone. So smart grid actually envisages the usage of advanced metering infrastructure. It is otherwise called as AMI. And lot of smart meters are also deployed, so that you can easily detect the fault, you can identify the thefts also, you can identify or quantify the losses also. And you all must agree, our neighboring union territory, Pondicherry, has got a pilot model on this kind of smart meters incorporated into the smart grid. So the Pondicherry
Hello. Yes, ma'am.
Sir, voice is not audible.
Some network issues, ma'am. She has left the meeting. She will join soon, ma'am.
Okay, okay, okay. Thank you.
Okay.
Sir, can you listen, hear to me now?
Yes, ma'am. You are audible.
Sorry, madam, I didn't know that it got disconnected.
Uh, yes, ma'am. That's why we called you. It happens, ma'am.
Sorry, and kind enough Jagdish sir has informed, and I hope the introduction given by me, I will repeat once again. Um, so it's a immense pleasure. Dr. Jagdish, in short, is a very nice person, and his efforts are really remarkable because I'm very happy to say that I am his colleague in SRM. He's a very nice and helping person, and this topic, what he has organized, is the need of the hour. Why? Because the next important word in the industry is IoT. Everywhere you see, they call Internet of Things, but the next paradigm has shifted as Internet of Everything. You call it as IOE, right? Sometimes they also call Institute of Eminence. In our university, we are struggling to get IOE. That is another context, but certain other universities have given IOE status. So IOE in another context stands for Internet of Everything, right? And the industry is going to have a paradigm shift to the Industry 4.0. And what Jagdish sir has organized, the topics are very vital in the present day because lot of things can be done. And as a researcher, this particular forum will be very useful to the people who are aspiring to do even research. And we should thank ATAL scheme for giving an opportunity so that we are able to share our knowledge in this online platform. And I hope it will be of great use to you. So let me start my presentation with this small introduction. I will try to give you an overview about why we move to IoT and what is the need for moving to IoT. And this IoT is actually the word taken because of the present grid is going to be a smart grid in the coming days. By 2035, we expect the entire traditional power grid to be a smart grid, right? So what was the drawbacks in the conventional grid? If you take the traditional power grid consisted of large amount of loosely interconnected synchronous alternate current machines embedded into the grid. So they were performing three main functions. That is the generation, the transmission, and the distribution of your electrical energy, in which your electrical power flow was happening only in one direction. That means there was a service provider who will be able to supply only to the consumers. The so-called service provider with respect to our state, Tamil Nadu, is called as the utility board, TAN GETCO, Tamil Nadu Generation Distribution Company, right? So what happened was the power generation was happening because of the large amount of power plants which are actually burning the fossil fuels, and sometimes they were also burning these uranium based fuels which we see the Kudangulam power plants. That means I'm talking about the nuclear power plants. These are the major sources of our conventional power grid. So they were actually creating lot of pollution. In the sense they are creating kind of a hazard like SOx, NOx and other kind of pollutants are being released because of the burning of the fossil fuels. So the generated power from these conventional power plants has to be transmitted via high voltage transmission lines. So there came the help of transmission systems. So there is a utility in our utility board. It is taken care by TAN Transco, Tamil Nadu Transmission Company. That means we have sold or we have gone for a deregulation in our existing utility system. That means we have actually kept the generation and transmission as a, what do you call, the privatization has been done in the sectors so that we are able to have it as a three separate entities: TAN GENCO, TAN Transco, but TAN Disco, Discoms, distribution companies. So this is how our system of conventional power network is happening. Then comes the distribution network where your electrical energy are being delivered to the end consumers. But what happens when you deliver the electrical energy to the end consumers? There is going to be a reduction in the voltage because of the drop in the transmission lines. However, these grids are centrally controlled and monitored so that you will be able to establish the probabilities of meeting the generation with respect to the demand. But that is not possible because of the growing rise in the demand, which always created a vacuum so that our generation was never equal to the distribution system or the demand, right? There was no balance between the generation, whatever we generated was not equal to the demand. So what I can call is the traditional power grid since the inception of 1870 until 1970 were only unidirectional. We didn't think of a bidirectional kind of a concept, right? That means we never thought of something modernized grid. But however, the demand was growing very exponentially. However, the generation was only very less, right? So there happened now after 1970, the loads were actually become the loads are now actually having electronic devices based loads have come into the network, and the fast growth in the electronic industries has definitely helped in the modernization of the grid. And our present grid since 1980 onwards, if you see, it is no longer based on conventional power grid. It is now renewable energy based power grid, right? If you see 1980 onwards, we started deploying large number of wind energy conversion system into the grid. So that three regions, we call it as Kayathar, Aralvai Moli belt. Then we have the Udumalpet belt. So these are the three wind belts in our state, and we should proudly say that Tamil Nadu is a state rich in three renewable energy resources. So we call Tamil Nadu to be a RE rich state for the wind, for the solar, and for the biomass. For the wind, fortunately, we have the Center for the National Institute of Wind Energy. It was originally called as National Institute of Wind Energy in the present days. So NIWE is it was originally called as Center for Wind Energy Technology, CWET. Now it has been renamed as NIWE, National Institute of Wind Energy. And they are the nodal agency for actually accounting or giving certification for all the newly developed wind turbine machines. So if you have an opportunity, try to visit Kayathar, where you can see since 1980 onwards what are the turbines being invented and how it is being deployed, and all those things are available and running in the Kayathar Wind Resource Assessment Belt. So that's a very beautiful place to visit. Then if you take the solar, again we are now doing lot of work, and we have an ambitious target. By 2022 we have to pump in nearly 175 gigawatts of renewable energy into the existing power network. So the existing power network is still trying to become a smart grid in the coming days only. So among the 175 gigawatts, 100 gigawatts will be coming from solar route, right? And remaining 75 gigawatts, in that 60 gigawatts will be from offshore wind turbines and onshore wind turbines combination. So in 175, 160 is already fixed now. So remaining 15 gigawatts is left out. In the 15 gigawatts, 10 gigawatts is going to be taking place through the help of mini hydros. So in our country, mini hydros are also getting popular. If you take as a whole country as India, lot of mini hydropower plants are all slowly coming up, and they are also a source of renewable energy resources, and that is going to occupy the remaining 10 gigawatts. And remaining 5 gigawatts will be from other sources. It may be tidal, it may be etc. etc. But with respect to Tamil Nadu, we are rich in these three resources. So what's going to happen to the traditional power grid? Since 1870 inception, it was unidirectional. Now, after the invention of microgrid and the Internet of Things and other components of IoT like big data, cloud to edge middleware, the gateway, the sensors and the actuators, all these things has provided that our grid will become a smart grid, and we are going to have a better grid in the coming days. And if you see in the first introductory slide also, I put some electric vehicle getting charged with the help of IoT, right? You see in my first slide. So these electric vehicles are also going to make a bigger impact into the existing distribution network. Why? Because our existing power network has to bear this as a load now. So for all these things, we need to build a good infrastructure, and that is possible with the help of the paradigm shift of the smart grid. Somebody is talking over the other line, I think, madam. Can you mute your mic, madam, because I'm getting interrupted? Okay, very kind of you. So smart grid paradigm shift is going to be a promising solution for us, because there is going to be a bigger kind of a contribution from the information and communication technologies, so that our existing power grid will be improved in terms of effectiveness, efficiency, reliability, security, sustainability, stability, and scalability. So all these, yes, right, has given improvement of yes. Yes means sustainable, stability, etc., etc. So our smart grid is going to make this as a promising one, because smart grid is going to be a bi-directional communication flow, which will happen between the service providers. Who are all the service providers for our Tamil Nadu state? The Tangentco. And the consumers. You are all the consumers, right? Me, you, and everybody are going to be the consumers. Whereas when compared with the traditional power grid, it was only unidirectional. So in the modern power system, the smart grid are going to provide advanced metering infrastructure. You call them as AMI. And there is also going to be a provision for smart meters. And these smart meters will have a fault tolerance, and they can actually detect the theft in the power, and they can also really quantify the losses happening in the system, because around 30% of the T&D losses happening in the present conventional grid, which will definitely be minimized if you're going to go for a smart grid with smart meters. And they can also do load balancing, and the smart grid can definitely do self-healing, and even it can detect the faults and also recover the existing network from the faults. So in short, what I can call is, it is a very boon for the system, traditional power grid. And the best example lying before us is very adjacent to Chennai, that is the Pondicherry Electricity Department has deployed nearly 1,500 smart meters in and around the Pondicherry city, and you can now quantify the real consumption of electrical energy with the help of smart meters. So this was funded by our PRNDC, and they have made a pilot project, and it is showcasing the need for smart meters in the smart grid, accounting the energy consumption pattern. Thereby, you can minimize the losses and you can minimize the thefts and maximize the profit. In terms of identifying these losses will try to help us in determining a effective system. So this smart grid helps us in doing real-time pricing, self-healing, power consumption scheduling, and it is also going to give an optimal energy usage. So what does the smart grid basically does means they are having various types of devices for monitoring, analyzing and controlling the grid. So such monitoring devices are actually going to be deployed at the power plants, on the transmission lines, on the transmission towers, on the distribution centers, and also at the consumer premises. So what is going to happen is millions and millions amounts of data will be collected and you will be able to account for the real problems or real challenges faced in the system. So smart grid actually envisages a good connectivity, automation and tracking of large number of devices which require actually the distributed monitoring, analysis and control with the help of high speed, ubiquitous, two-way digital communication. So smart grid now for such devices are going to become for things. That means the real world through Internet of Technology, Internet of Things technology is going to help in making the smart grid itself to be a viable solution for the coming days power network, right? So you are going to make a distribution automation of the smart grid with the help of IoT. So our topic for today is IoT. So we can define now this IoT as, I think I have given some definition here. It is nothing but an object with the internet based on a protocol for exchanging your information and communication among the various devices so that you can achieve a very good monitoring, a tracking, management and location identification objectives. So IoT in the present day has gained significant attention in various applications so that you can have a better network with the help of various network embedded devices that will be embedded into the network in our, and it will be available in the daily life. So internet is going to play a major role and that has only helped the people to connect. So even we are getting connected with the help of internet, right? Dr. Jagadish sir is able to organize this workshop in online mode because of the internet, and everything is made possible via online nowadays after the COVID situations. So I hope now you all agree IoT is a very important topic and we must congratulate the organizer once again on your behalf that he has chosen a right topic to be delivered on this occasion of post-COVID situation, right? However, by 2008, the number of things which are getting connected to the internet surpass the number of people in the world. That means the impact of IoT technology keeps on rising. So IoT is now called as a network of physical objects or things which are actually connected to the internet. So what happens with these objects? These objects are actually embedded with kind of a embedded technology, or you can call they're equipped with an embedded technology so that they will be interacting with their internal as well as the external environment. So basically what does these smart gadgets does? They actually do the sensing, they do the analysis, they also can do the control, and they also can make a decision whether this is individually they can operate, perform well, or in collaboration with other objects, you will be able to get a very good speed, and also two-way digital communication is possible to the system. So exactly IoT is going to help the smart grid by supporting various network functions throughout your power generation, storage, transmission, distribution and consumption by incorporating the so-called IoT devices. So what are IoT devices? Anyone can tell me? I have given this is a small idea what I am trying to talk in this first half an hour. So I wanted to talk about IoT. So you saw the definition of IoT according to my application. Then what are the sample IoT devices? So let's see here. These are all the IoT. So they are nothing but they are going to have some sensors, some actuators and smart meters which are put together, are going to provide a good connectivity, and they will be helping in the automation as well as tracking of all these devices. So smart grid is going to be considered as the largest application of the IoT. I can conclude or say like that. It is actually going to help in the connectivity, making a bigger application for the IoT. So the global standards for communication actually talks that IoT is going to be the future in connecting the smart grid, so that you can comprehensively cover the IoT aided smart grid systems to all the other components in the system. Thereby you can have a better understanding of the power system. So with that introduction, I move on to my presentation slides. So you could see the role of IoT it can be extended to all these application areas. So taking the smart grid, for that was the first. You could see on the slide, smart grid is the area what I was trying to project, because I'm going to talk on power quality. So in the smart grid environment only, power quality is going to be coming up, and that is the reason why I've chosen smart grid. And you can easily deploy in smart health, smart home, smart cities, smart industries, where industry 4.0 is used. And now many of you in this participants also would be owning a smart TV, right? You can watch everything in the TV. Even you can map your mobile phones, and you can watch, you can browse the like what do you call, the smart TV, and use it as a computer also, right? Computer screen, it can be connected to the CPU, so that you can also do your other operations by in a bigger screen called as a smart TV. And very obviously most of you would also have bought now by this time smart watches introduced by Apple, MI, etc., etc. That's also going to be a smart car, right? That is also going to come in the electric vehicle technology innovation. It is going to come. So smart kegs. So these are all the different applications. I think this is the way even the presentations are also organized. The tentative schedule is also talking about smart home, IoT for smart home, etc., etc. I saw the schedule yesterday, Dr. Jagdish has sent. And by that way, you guys are also called as smart guys, because it's fortunate that you're all attending this forum where Dr. Jagdish has made you smart and is going to make you completely smart after the end of the workshop. I hope Dr. Jagdish will agree with me, because the smartness is induced by the passive, the active, and in terms of awareness and in terms of autonomous, all of you will become smart at the end of the 6th day or the 5th day of the workshop. So what do you mean by your passive in smart? The word smart. Passive is nothing but it will communicate only when you are going to give some query. Take it an RFID. When you pass that information to the sensors available, you try to detect it, whether what is inside. That you pass the RFID and you check it. That means it's a passive RFID. Sometimes the QR codes, right? Whereas active is something different from the passive one. Here communicates when needed, like sensors or home automation, etc. Right? Whereas in the RFID, you communicate only when queried, right? Somebody is going to query, only you're going to communicate. So that is called as a passive mode. But all these things are the subcomponents of smartness, and you must be aware of the simple computations, right? So if you take telehealth, that's a company doing very good thing, Fifth Sense company, right? And you can Google it and see for further information on how are these people are utilizing the same concepts of IoT. And finally, I could call anything which is autonomous. That means it is going to make decisions on the rules assigned. It is called as a smartness embedded into the system. You call the autonomous cars. You also call the smart grid, right? You already try to give them all possible combinations, and you have put all your smart meters so that you can make it to be a smart system, right? So as per our IoT applications are concerned, these are the most 10 popular IoT applications. Smart home, starting from smart home, everything is, you should start from home, they call it, right? So from smart home, it becomes smart city. From smart city, it becomes smart grid. And finally, if you see, there's going to be a smart supply chain also. Now, if you see, a lot of apps have come. super daily, etc., etc. What do? You try to place the order, they try to deliver it to you on time the next day morning before 7 a.m. to 8 a.m. So that much things have become very much deployable of IoT into the grid, and people have adopted lot of things into their networks. So next important thing is, we said the sensors are very important. Sensors and actuators are going to form a very important component of IoT. So we need very good sensors. So these sensors basically, are they going to be a cheap sensor? Or are they going to have a cheap bandwidth? Are they going to have a cheap processing? What else? What is that you are looking for actually? Let us take a smartphone. So you see there are a lot of sensors in the smartphone. Nowadays, when you see, when you blink before the smartphone, it tries to open it and you are able to access your own data. So that much amount of smartness has been introduced already in the smartphones, and you could see it is going to have a ubiquitous wireless coverage. And this is possible with the help of a concept called big data analytics. And mostly these sensors have to be a IP certified sensor. That means IP version 6, right? Ingress protection should be of V6, right? So this is how the IoT is actually going to look in the network, right? So you are having your home, you are having your infrastructure, the transportation, especially the BMS. Maybe if opportunity is given, I will be talking on BMS for electric vehicle. There was a IoT based BMS, and I can also extend the part 2 of the power quality with the help of a case study. Well, let us see how it goes about. Let us understand the fundamentals. What my objective today to come and address to you is, tell the importance of IoT into the smart grid, and in the smart grid only the problems of power quality is going to arise. Why? Because this smart grid are deploying power electronic devices, right? So when you deploy some power electronic devices, definitely there are going to be a source of power quality problems arising because of introduction of power electronic components. So you need to introduce some filters, and that will solve the problem. So if you see, IoT is going to occupy the industry, the retail segment, the healthcare segment, the consumer in the home, etc., etc., right? So that is why the smart homes have come, and the appliances in the smart home, the home, can be communicable with the help of these IoT sensors. So these sensors will help us to take decisions on the readings consumed. For example, you come out and now you are going to attend this lecture. You forgot to turn off your geyser. So what will happen? Your geyser will keep on running, and your EB bill or utility bill will be rising high. So you need to have a kind of a meter which is going to inform you that the power is getting consumed during the peak times, and if you're going to use it, your EB utility bill is going to be very high. So the role of IoT is felt here, and thereby you can curtail some of the loads by working in your work environment. You turn off the loads, and similarly you can also turn on the loads. So power grid, in power grid, the power distribution to the smart home and the guideline pricing based on the past peak hours seen only. This is what being done in the power grid, right? And the smart meters are definitely going to be a digital meters having some smart chip and scheduler, which will actually going to make decision on scheduling the electrical home appliances based on the guideline price received from the power grid. Okay, so if you take an example, let us see. This is an example, beautiful example, helping us to formulate based on time of the day what is the price cost, and so that you can calculate which is the peak hour pricing graph. So when you determine this graph, our job becomes very simple. We put it onto a scheduling algorithm, and the scheduling algorithm gives us the information that when you exactly want to charge your system, where the battery load is less, and the what do you call, the primary system, the master system will be having energy and it is not dissipated. So over is getting reduced because of this. During peak time, if you turn on that, the utility bill may rise. So in that context, you try to account for the maximum consumption by reducing the minimized consumption with the help of IoT. So let us see a beautiful picture now about smart grid. Here, the smart house actually waits for the price of electricity to drop. So then it will turn on the dishwasher as well as other equipments in the home, right? So in this way, you can reduce the electricity cost at peaks, and your house is actually going to have a better system prevailed because of the IoT concepts. So if you take the charging vehicle infrastructure, in that what is going to happen is at night times when electricity is least expensive, at 7 a.m. the house will tell the car to stop charging and use the battery to power the coffee maker in the kitchen, right? So this is how it is being done with respect to electric cars. Sometimes these solar cells and windmills are going to light up another kind of a thought. That means solar heating is going to keep your kids as warm, as well as at noon the school has more power stored than it people so consumed with the help of smart grids and smart grid distribution that will help us, so that the schools get a power credit also, because they are going to generate the source of renewable energy and pumping into the grid. That way they become self-reliant also. Similar manner, you can, whenever lightning is striking on the system, what happens is there is going to be a problem. So smart grid actually takes it out of the loop. A dozen smart grids, smart microgrids immediately access stored electricity in homes and cars, and all the power from the solar panels and windmills will be getting distributed where it is needed the most. So no service is going to get interrupted. So that is also possible with the help of smart grid system, right? And this is a home scenario, right? You connect all the gadgets in the home with the help of your LAN or nothing but internet connectivity. So what is happening? You are able to get some kind of a effective system in terms of controlling the smart home scenario. So what I can call, the same slide is getting repeated, smart meter apps has also come. Thereby also you can do the similar process. So now we move on. How exactly IoT is going to solve the problem, right? Till now we saw some overview about IoT and idea on power quality, right? So the IoT can solve, these are the following things, right? It can tackle the safety, it can tackle your losses, or in other words, I can call it, it can minimize your losses, and the cost can also be drastically brought down, and the choice, we have a better choice now. Whoever is going to generate cheaper, we can buy the power from them, right? So thereby what happens? You can actually reduce the peak demand consumption, and your utility bills can also be reduced. So the complexity at scaling level is only going to be the bigger problem before lying with us. Once we overcome that, definitely the IoT in smart grid and in power quality monitoring will be of great help in the coming days. So in this outcome, some researchers should be present addressing this 6 days workshop. So IoT for distribution grid monitoring and control. This is a very important area where you guys can start your research. And second area is IoT for distributed energy resources, the integration and the monetization. So this is how IoT is going to play a vital role. And this was what I was talking in terms of components of IoT. So definitely IoT has the following components: a big data. So what is this big data? It stores time, it shows a voluminous amount of data which are unstructured, and they're going to be actually connected with respect to the context, and they'll be available in the API for enterprise solutions or enterprise applications. Next comes the cloud to edge management. Here you can manage your data and edge devices, etc. And data streaming is also possible with the help of cloud to edge middleware. Next comes the gateway. Here in this gateway, it is nothing but it's going to collect the data from the sensors and abstract the protocols, perform the local autonomous direction and transmission information systems, right? So these three I have discussed. The last one is the sensors and actuators, which are definitely going to connect to the smart grid, so that what happens is your data can be easily sent, and it can be taken whenever needed, and it is also a secured platform consuming less power, and it will be easily to transfer or to install. That is also possible. So you can see how exactly smart meters are happening. Smart meters, smart submeters, for PV batteries, substation monitoring, feeder monitoring and control, and generation monitoring and control. So we move on to the open source scalable architecture of smart grids. So if you take the IoT gateway, actually is connecting all the other gadgets to the IoT gateway. From the IoT gateway, it will be given to other loads to be connected. So you could see a solar, you could see a battery management system, and you can see a hybrid electric vehicle. Okay, so these are going to come into the existing network. So this is a forum on smart grid has already been started. It is called India Smart Grid Forum. So please note that and visit that website. We have also delivered the one lecture in Smart Grid Forum. We visited, I think, 2017 or 2018. It is available. This center is India Smart Grid Forum is located in New Delhi, and if you are unable to go there, at least try to browse the net so that you will get a lot of information about the smart grid forum. And batteries are going to play a very important role. The evolution of batteries started like a slowly, and now we are able to have a more better option with the help of IoT based system, IoT based smart grid and also quality environment. So if you see, these are the gateways that must be provided. You must have a protocol abstraction from SCADA metering to the internet, and you should have a computing and input IO performance for the real-time process, and it should also be integrated communication capability of sensors and actuators. These are all the roles which will be done by the gateway. So few of the gateway manufacturers are Dell, Contron, and Adlink. These are all the famous companies available in the present world. So this is how IoT sensor will perform. So example of smart grid edge devices are utilities, which I told you already, Tangentco for our state. The other sensors are voltage and current sensors, smart inverters, smart meters, smart RTUs, feeder monitoring and control devices. So the one important part in this is also left out. There is nothing but active grid management. Using the so-called IoT, you can actually do or monitor the energy consumption, and you can also reduce the losses, right? So reduce peak load by dispatching or distributed flexible resources. Then the last thing is you're going to maximize the use of your existing resources, so that this can be definitely scaled up to large capital investment. Okay, if you see here, these are the benefits which are going to be offered by monitoring and the control of the smart grid in an effective manner. So these are some of the representations of the gateways which are actually forming the building block. So the IoT gateway must provide a protocol and the device manageability is also very important. Security management is also very, very significant, and you need to have a data scalability. So all these things are going to help us, and few more also there will be. The IoT gateway must provide these features along with the existing one, right? So with this small idea about IoT, I move on to the actual presentation of power quality, IoT enhancement for your power quality. The IoT will help in the power quality enhancement. This is what in simple you call it. So I hope you have noted down my mail ID. Right. Let us move on to the my second presentation. That is, I prepared an elaborate one discussing about the significance of the monitoring of the electric power quality using IoT technology. So I hope you can see this slide. So this is the actual presentation, but before going into the topic, this introduction is very vital, because then only you can understand what was happening and why we went to IoT. Let me summarize before I enter into the topic of discussion. we discussed about the conventional power grid, which was started during 1870 onwards. Then in 1970 up to 1970, there were not much improvements. And what happened now, because of the smart grid, your IoT gained a lot of momentum, and we are able to have a better environment because of smart IoT, right? Why is power quality is of use to us? So that is a question for us. Like if you see, the worldwide energy demand is actually increasing, right? And these it is also expected that global energy consumption will increase by more than a more than a third in the period of 2035. So this is going to happen in the year 2035. So we are having a longer way, but this is now what we are doing is capacity building. That is what I was telling. Even Jagdish sir I was congratulating here. He is making a beautiful capacity building by bringing very good participants from different parts of the country. So it is expected that the global energy consumption will increase by more than a third in the period of 2035. So you see, one end your energy consumption is also going to increase. So then where will be happening of generation taking place? And even if generation was done with the conventional power plants, what was happening was there was a large amount of power threats, losses, etc., etc. So finally, all these things have motivated me, and that has helped me to deliver this lecture. Why? Because we can continuously predict or follow up with the demand increase, and that will help in the better conditioning with availability, with the electricity availability, right? So combination of direct load current, algorithms and other things are being done so that you can have a good demand response, and also lack of end monitoring. That also has to be taken up so that we are able to resolve the issue. So this is what I want to talk about power quality issues. Now, why power quality is going to be of use in the present environment. So I hope you are clear. I recollected everything. So slowly we are moving on to the topic called power quality. And this is a very voluminous presentation because I am prepared for more than 2 hours. Right? So let us go one by one. How do you define power quality? Please, anybody can tell me what is power quality? It is nothing but, according to me, is a product of voltage quantity into current quantity. So out of these two quantities, which is in your control or in our control, is voltage quality. Current control is not possible because the loads, especially we are also the loads to the grid now. Let us take our home scenario. So I am the source node. you are all the loads located at the distribution end, and the applied voltage is only in my control, but the current drawn by each one of you are going to be unique. That means one will ask for 6 pulse converter, another guy will ask for 12 pulse converter, etc., etc. So what is going to happen? The voltage quality is only in our control, current quality is no longer going in our control. So what will happen? Finally, the power quality is going to get affected. So PQ deterioration is one of the very important challenges to be envisaged in the smart grid, in the IoT based smart grid, right? Sometimes you can also have a brownout happening in the premises. So in our own premises we had a brownout, so that was because of that is also one of the important power quality issue in the system. So we tried to overcome by providing proper surge protection devices. So the problem was very simple, but if you take it other way, if you are not able to locate the problem, you are really into trouble, right? So voltage sags are also predominantly seen whenever you turn on large amount of consumers in the same locality. So others, it may seemly, or it may also be less. So we don't know about that, but you can Google it and see. So let's see the usage in also elaborate. I think it is the only in kind of the standard to be followed here is EN 50160, and also we have to follow the IEC 61000-4-30. So these are very important standards. If you want, you can download them in Anna University, right? So let me show you a quick video how you are actually preventing the fault with the help of power quality, right? Let me show this. Entire screen, right screen. Okay, wait, I think it's not playing here. Once again, I will show it directly from the video file. Okay, this will help us how exactly the fault is getting prevented. Then I have got to tell some case studies also. Just hold on. It's taking time to load, I think. Okay, it's not responding. Okay, before the video gets loaded, I will try to throw some more light. In the family of power quality, there are a lot of members like sag, swell, harmonics, etc., transients. All these things will be forming the member of power quality. So we will be seeing this also as an idea in this video. Let us listen to it. I think it is need to get loaded. Just wait. I think now you got some idea, and practically Siemens is one company doing a lot of things on power quality monitoring. So just to give an idea how industry is working, right? So if you say these are the gateways, right, to be built to account for the uh, power quality problems, right? You need to monitor them. Otherwise, these faults are going to cause huge problem to your network. So what we have to do is we have to have a provide a proper gateway, and we have to have a device manageability, we have to have a security management, we have to also have a data scalability. So you place these voltage and current sensors, etc., smart meters, etc., onto the system. Thereby, you are going to monitor your power quality, right? So we move on now to the rest of the lecture. That is, wait 1 second. I'll get back to you. So we now got some idea actually how industry is working. So these are the different power quality problems prevailing in the network, right? You have to account for flickers, unbalanced, sags, swells, transients, interruptions, harmonics, etc. So how is that you're going to do it? Schneider Electric, I told you, they are actually capturing the benefits of having a good power quality by demonstrating with the help of their own devices. Thereby, you can account for the theft of the energy. So there are a lot of mathematical tools like Kalman filtering that will also sense, and it will iteratively do the mathematical process to quickly estimate the disturbance present in the network. And every technology embedded into the smart meter will have a good communication network, a data processing and management system, as well as an installation unit. So it has to obey IEC 61004-30, and it also has to obey EN 50160. So there is one more video on power quality, but before going to that, I like to show you some of the standards for PQ. So it starts from IEC 61000-1, and 1 stands for the definitions and methodology. It goes up to 6. So these things has to be taken care when you are going to do real-time PQ monitoring, and these standards will help in identifying the emission limits for the individual equipment which are connected to the medium voltage and the high voltage system, so that you can have what are the admissible values to be allowed. So stage 1 will be a simplified evaluation of the distribution emission, and in the stage 2 you will have a emission limit which is relative to the actual network characteristics, and in the stage 3 you are going to give an acceptance of higher emission levels on an exceptional and precarious basis. So what is this EN 50160 standard of power quality meaning? It is actually the European Commission, and it stands for Electrotechnical Standardization, formulated in the year 1997. And this is actually going to specify the voltage characteristics at all the customers' supply terminals. Again, it can be the public LV and MV electricity distribution network. and according to it, it should not violate the norms prescribed for the individual harmonics of odd and even harmonics which are given in the table. So this is another simple calculation program developed by few of the researchers in estimating the power quality problem. They try to capture the voltage and current waveforms and they pass on to the algorithm. This algorithm will try to determine what are the power quality problems present by taking the fundamental frequency for analysis. That means from the in the voltage and current waveform, they will try to eliminate the fundamental. So when you eliminate the fundamental, it will be the remaining will be the disturbances, right? It is x plus y is equal to z. But x plus y, in that x plus y, x is the fundamental. If you remove, means you will know the what are the harmonic components or what are the other disturbance components present. So that disturbance component you will be able to estimate with the help of the standard coding available for each of the power quality problems. So when you pass on to that algorithm, it will try to tell whether the disturbances has got either flicker or harmonics or whatever, unbalance, etc. And you can have a combined system which will give you the monitoring of the PQ. So in the case of a microgrid, what you do is you again put an active power filter at the front end, right? You have a distributed generation connected to the inverter, but these distributed generators are actually utilizing power electronic devices. They may inject harmonic problems into the network. So that is actually going to pump the PQ issues into the network. So you are able to see that onto the system, and your power system network is you can monitor them with the help of your PQ monitors. So the first generation of power quality indication devices are your passive power filters. Then becomes the active power filters, the shunt active power filters, the series active power filters, and the hybrid active power filters. This is how the PQ improvement devices started coming. You can all the second generation also started deploying in the network. That is a DVRs, which is a voltage compensating device, and you also provide AVRs, automatic voltage regulators. This is also very important to improve the voltage. Whenever there's a critical load voltage, you have to improve them with the help of AVRs. And StatComs are also provided into the network, which is a current compensating device, improving the system. Right? You have UPS. This is also one of the improvement device which is available in the present network. So what basically these things are doing is they are actually going to mitigate the power quality problems faced in the network. So let us go to the one more device, which is nothing but unified power quality condition. It is a combination of your shunt active power filter and series active power filter. So which is again going to solve both the problems because of current and voltage related issues, which will be solved with the help of UPQC. And this is one such example which we simulated in our laboratory. So here you have the series and shunt compensating device, and your non-linear loads or your UPS loads are taken for understanding. So basically UPS loads, if you take, it is going to inject NP plus or minus 1th order of harmonics. That means 5th and 7th order harmonics will be predominant. And sometimes there may be problems of voltage related issues also coming. So we need to deploy a series compensating device which will try to compensate the voltage related issues. So these are the different PQ conditioners deployed onto the power network to improve the power quality problems. So we need to go for a permanent monitoring solution onto the grid so that we can account the power quality. Then we can, once you know the characteristics of the power quality problems, corrective actions can be taken very easily. So monitoring of the specific problems becomes very significant. Thereby the further problems are eradicated, and it will help in the the improvement of the entire system. So enhanced power quality services is going to be a very important talk in the smart grid environment. So the information we can summarize as, first we should see what is the nature of problem, what is the characteristics of the sensitive electronic equipment experiencing these problems. Then at the times when the problem occurs, you will be able to come out with the suitable solutions so that you can modify the existing network. Thereby the power quality problems are eliminated, right? So this is how in a real network PQ monitoring is done. You could see there's a transmission system and a distribution end. At the distribution end, you are having your customer monitoring system where you are putting lot of AMI, automatic metering infrastructure are deployed, where you collect all your data and your power quality energy information services are available, which will be put it to the cloud, and that cloud from the cloud database you can retrieve back the data, and so that you can do your reliability assessment also. And if the power quality is poor, you can definitely make some corrective mechanisms, right? So your digital fault recorders, smart relays, and other IEDs, voltage recorders, in-plant power monitors, all are going to help in the power quality estimation. So this is one video which is tell you about how the power quality is getting monitored. So I think with this, I will give you it will give you a better idea how it is being done in the network. Let us listen to this video. I think there's some transition taking place. Just hold on.
In this segment, we will discuss.
Oh, sir. I think instead of closing. Again, this is also by Schneider Electric.
In this segment, we will discuss 4 typical phenomena that can occur in an electrical distribution system. We will begin with harmonics. Harmonics are high-frequency current and voltage. These stress the electrical distribution network, being that most electrical distribution networks are a stiff or low impedance system. Voltage distortion can cause distortion of control signals and stress electrical equipment's dielectric material. Current distortion increases the electrical distribution network RMS current that can cause skin effect on a conductor, overload transformers, and nuisance tripping of circuit breakers. Keep in mind that single-phase nonlinear loads like switch mode power supplies and lighting ballasts cause zero sequence harmonic. Third harmonic order or triplet harmonic that, in a Y configuration, add up in the neutral conductor of a Y system that can lead to neutral conductor overload. In a delta configuration, get trapped in the delta of a delta system and can initiate magnetostructure within the transformer in question. All these effects can lead to premature equipment failure. AccuSign is ideal to remove the high-frequency current from your distribution network, which in turn reduces the voltage distortion by stopping the flow of high-frequency current through your electrical network impedance. The reduction of total harmonic distortion current and total harmonic distortion voltage removes the stress on your distribution network. Power factor determines how well you utilize your power. It's the simple ratio of your real power over your apparent power. The general engineering practice or rule of thumb is to keep the power factor in an electrical installation above 90%. Why correct power factor? It can reduce utility bills by reducing your demand charges, which relates to your rate structure. It reduces apparent power, therefore reduces loading on your power transformer and distribution network. Reduces I2R losses. Electrical distribution systems have losses ranging from 2% to 5%. Correcting power factor reduces the losses by 1 to 2%. Reduces carbon emissions since we reduce the I2R losses. Improves voltage regulation by correcting the power factor. We reduce the loading on the network, therefore reducing the voltage drop across the network impedance. The most cost-effective way to correct power factor is to use automatic capacitor systems. They're typically installed at the main distribution board or in the MCCs. The VARSIT system is suited for small and medium-sized networks up to 1,500 kVA and in large installations up to 5,000 kVA. Flicker level is discovered by using the short-term flicker coefficient, or PST. Flicker is caused by a series of voltage fluctuations and depends on both the magnitude of the fluctuation and the frequency of the fluctuation. Flicker is normally caused by large inductive loads. When a welder strikes an arc or an inductive load starts, they demand large amounts of inductive reactive power. That makes the voltage sag repeatedly, within milliseconds or seconds. Flicker may cause process downtime or generate poor quality products. Furthermore, utility companies may force the consumer to mitigate flicker if they're creating power quality problems on the utility distribution line. To solve flicker, the AccuSign Plus in power factor mode can be used to inject capacitive reactive power to counteract the inductive reactive power demanded. To be successful in correcting flicker, you must inject the right amount of reactive power within one electrical cycle. This makes the AccuSign ideal for the job because it's scalable. You install the number of units you need in parallel, and it can inject kVAR within 1/4 of a cycle, 4 to 5 milliseconds. Chronic undervoltage can happen because the consumer is at the end of a distribution line. The neighboring customer may be starting a large inductive load. The consumer may cause the sag with their own industrial process. Chronic overvoltage normally happens because the utility is switching capacitor banks on the medium voltage network. A large load is switched off within the client's facility or the medium voltage distribution line. The SureVolt automatic voltage regulator can take a voltage input ranging from plus 10% to minus 25% and regulate the voltage supply to plus or minus 3% within one cycle, making it an ideal solution for chronic voltage issues. Deeper voltage sags are normally caused by short circuit events and or by operation of a utility recloser. For these deep sag events, the sag finder is the solution. It can correct for 70% sag on 1 or 2 phases, or for 40% sags on 3 phases within 1/8 cycle, and boost the voltage back to 95% of nominal value.
So I hope you understood the problems of PQ, and there is a case study. I can share the presentation materials also, because if the time is there, I can present the case study based on one work we have done, and it is available for discussion. And sir, can I continue, or in the part 2, if there's an option for me to continue, I can deliver these are the things. This is a case study on real-time monitoring and control of the energy flow and power quality. It can also be discussed. So, Dr. Jagdish sir, is there time, or sir, what can be done, sir? I hope you understood to some extent. Dr. Jagdish sir. Hello. Madam, can you hear me?
I think 5 more minutes there.
Okay, okay. Then I can show that results what we have done it. It's a audio is
Sorry,
not
ma'am.
coming.
Hello.
What happened? The audio is not there.
Yes, ma'am. Try again, ma'am. We were stuck up in a meeting, ma'am, so we couldn't monitor.
Okay, okay, okay. Like I can share these materials also to the participants if the audio is not. I think they have not listened to the audio. They have written. Just now I'm
Yes,
seeing,
ma'am.
madam.
If it is a YouTube video, you can share directly using a Google tab, ma'am. But directly, if you open the video, audio won't be shareable, ma'am. It
Oh
won't be
my God, I
audible, ma'am,
didn't.
in Google Meet.
Oh my God, I then you would not have enjoyed that essence of the video, madam. So shall I give that video to you by Google Drive? You can give it to the
Uh,
participants, madam.
sure, ma'am. Sure, ma'am. We'll share that, ma'am.
Okay. Any questions, madam? Like we have given some idea about what to be done on IoT.
Audience, if you have any question, you can unmute and ask, ma'am. Ma'am, shall we conclude the session then, ma'am?
Yes, madam. I think they're
Yes,
not. I think they've not listened to the audio, so there's not much question. But whether the
sure.
concepts are clear to them, because I have given some idea how IoT sensors are to be deployed.
Yes, ma'am. We were listening throughout the PPT. That was very useful, ma'am.
Okay, please find out because many have given the message that they could not. Audio volume was less.
They have asked for video, ma'am.
Ma'am, it
We'll
was
provide that.
audible, ma'am. It was audible. Thank you. Yeah.
Okay.
Your voice was clear, ma'am. It was audible. Only the sound in
Oh,
video was not audible, ma'am.
oh my. Sorry, I'm very sorry, madam. I didn't know that it. But last episode I took, madam. The students were able to listen to the video.
That
Audio
is,
also.
if we share it directly from the YouTube, the sound will be there, ma'am. It's
Okay.
okay,
Okay.
ma'am. We'll share that again in the drive, ma'am.
Okay. I will put it, madam. I will put it to sir. I will share it to
Uh,
Jagdish sir.
sure, ma'am. Sure, ma'am.
Any questions, madam?
I don't think so, ma'am. Thank you for the session, ma'am. Thank you for spending your valuable time with us, enriching our knowledge, ma'am.
Thank you, madam. But I don't know whether the audience got benefited. Lot of interruptions.
Your presentation was good, ma'am. So I would be listening
It
that,
was good,
ma'am.
madam. Thank you so much. It was really good. Yeah.
Okay, sir. Please make use of it, sir. Some more things are there. Maybe the time is also running. Maybe in second session, sir said we will try to connect and talk on EV also. Thank you, madam. Thank you very much, ma'am.
Yes, ma'am. Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Participants, the feedback will be shared soon. You can fill that and you can join for the next session in the same link. Thank you. Thank you for joining the session. Thank you.
Thank you.